Now you may be wondering, this sounds really stupid. Why should I hide away my member variables, all my integers and floats and chars and whatever they may be of my classes, so that I won't be able to use them directly, but instead I create functions, public functions, with which I will be able to access those very same variables? Why not just make everything public and be done with it, and I'll be able to access all my variables directly? Well, that's just the rules of object-oriented programming. Think about the real-world object of your computer processor. If you built your own PC computer yourself, you probably just bought one of these, pulled it out of the box, and stuck it straight into the motherboard, and abracadabra, it just works. The creators of this processor have hidden away all the details of the functionality of this computer processor. It's all locked up inside of this metal chip. I don't know or care about how exactly it works. All I care is that it works. And maximum, all I need to know is exactly how to use it. How exactly do I have to put it inside of my computer? Which wires exactly have to plug into it? And that's all I need to know. If this metal chip over here were coming in the box opened up with all the details and all the microscopic little wires all sticking outside, I could probably accidentally or not accidentally break things up, mess up the whole thing, change things around in the wrong way, which may end up by burning up my computer altogether. And that's what we're trying to achieve with object-oriented programming. We don't want to expose to you all of the member variables that every variable type that I created, every class that I created, has. First of all, because you shouldn't know about them and you shouldn't really worry about the details and the inside of this variable, of this class that I made. Second of all, if maybe one day you will start changing around the inside of the actual member variables, like this integer variable right over here, I may do accidentally stuff with it which wasn't intended by the creator of this C++ class. Like maybe for some reason the creator of this class never wanted the health to have the number 7. And if it does have this dangerous number 7, maybe for some reason the program will crash or something because this particular class had the assumption that health will never be the number 7. We'd like to hide away the actual variables that are inside any of the types that I create, any of the classes that I create, so that no one from outside touches around with them. The only thing we want programmers to worry about is to read the instruction manual about how exactly this class works and deal only with functions such as increase health, decrease health, attack, and stuff like that. And if at some point you actually need to know what is inside the variable health and strength, then there will probably be a function such as this one right over here, which will actually give me, it will return to me the health, the variable that I'm trying to get. So the actual programmer that is going to use this class won't care or know about playing around with the basic variables, the basic member variables that are in this class, such as these integers over here. Programmers will only have to worry about playing around with the functions that will take care of handling the integer variables themselves. Of course, if you'd like, you can disobey the rules of object-oriented programming and you can just make everything public, and that's it, everything will be accessible. But you will start seeing the logic in this way of programming once your classes become very, very big and they do a whole bunch of stuff and they have like maybe hundreds or maybe not even so many member variables. You will start seeing how it makes sense that programmers shouldn't really be messing around with the actual member variables of a class. They should just know how to operate this particular class by calling the correct functions, which will internally take care of the variables. So for now, let's just say that it's good to make all of your variable members private and all of your functions public. Later on, we will also learn how it's sometimes useful to have private functions, but we'll get into that some other time. So let's start using some of our classes a little bit more. Here we create an ogre and we'll call it A, and we'll create another ogre and we'll call it B. Or, as we learned about any other variable, we can create several variables on the same line separated by a comma. Just like you would create two integers in the same way, you can create two ogres in the same way. So here we have two instances of the class ogre. Each one has its own health, its own strength, and each one has the possibility of doing a whole bunch of functions, such as attack, increase health, decrease health, and stuff like that. Let's take away all the other garbage we had here from before, and let's start using these instances. So let's make each one of these attack. A, let's attack, and B also, let's attack. And let's see how this works so far. Compiling, linking, and here we go. Here is our program. I'm attacking and I'm attacking. There we go. Both of our variables, both of our ogres performed their action, their method of attacking. And the reason why we were able to call these functions with the dot operator is because when we, so to speak, read the instruction manual about how the ogre class works, we learned that there is a public function called attack which prints out I'm attacking to the screen. So because the function is public and it's meant to be used by any programmer that would like, so we have the possibility of making that function work by using the dot operator. Again, the dot operator is what we use to access the inside of a certain variable, a custom variable that you yourself created by making a class. And again, if I try to access the member variables of this ogre, like right over here, if I try to set the health of the A to 9 or the health of the B to 11, I will get a compiler error because I'm trying to access variables which are private. And that's the point, one of the major points of object-oriented programming, to hide away the details inside the member variables of a class, and all we do is just use functions to access the inside of how the class works. Now I'll repeat this again because it's very important that you understand the similarity of the classes that you create and the built-in types of variables that already exist, like integer. Just like I can create a integer x and then an integer y, I create a ogre a and a ogre b. And just as I do stuff with my integer x by either using the assignment operator or by increasing it or by doing a whole bunch of stuff with it, I also can play around with my particular variables of ogre by accessing what's inside of it with the dot operator. So it's wrong to type something like ogre equals 9 because ogre isn't an actual variable. Ogre is a type of variable. This is as stupid as typing int equals 9. Integer is not a specific variable. Integer is a type of variable of which you have to make an instance of that class. So just like I have to make an instance of x to be able to give it 9, I have to make an instance of ogre to be able to give it or start using the functions that this particular instance has. In C++, types of variables are called types. So integer is a type, ogre is a type. A specific variable that was created of that type is called either an instance or an object or something like that, or many times a variable. So x is an instance of type integer and a is an instance of type ogre.